Hello, I'm Professor Raymond Carlberg from the University of Toronto, and we're here in India to talk about the 30-metre telescope project, which we are developing in cooperation with India, China, Japan, and the United States, and University of California, and Caltech. This is my colleague, Gregory Fallman.
Hello, I'm pleased to be here in India. I work for the National Research Council of Canada. I'm the General Manager of NRC Hertzberg. We are the center that provides the national facilities for Canada in the field of astronomy. Great.
So we've had a wonderful time here in India at a TMT board meeting discussing how we're continuing to develop this project and bring it forward for funding and start construction in 2014. India has already made a commitment to the project to take about a 10% share. And we're talking about the details of the rest of the money and the technology that's required to make the telescope actually work.
Yes, I think we're very pleased to be here in India. This is only the second time that the TMT board has had an opportunity to meet outside of the United States. We had a meeting in Japan. We expect to have a meeting in China at some point. The Asian-Pacific connection of the TMT is very striking. Our telescope will be built on the island of Hawaii in the middle of the Pacific Ocean, very central to all the partner countries, including India.
So the 30-metre telescope will be built in Hawaii, which is one of the best places on the planet to put a telescope to make sure that it sees clear skies. The telescope itself, being the primary mirror, is 30 meters across, which is so large that everything sags, and so the telescope needs a huge amount of electronic equipment to keep everything properly in focus. And our Indian colleagues are experts in many of these areas to help us develop the computer control and the measurement components to make sure that everything's in the right place and properly focuses the light.
I think the primary mirror, although it is 30 meters across in a parabolic shape, is made of very many smaller segments, about a meter across, and these segments have to be very precisely positioned and controlled to maintain the shape of the mirror. And again, this is a task that's been entrusted to our Indian colleagues.
Of course, one of the wonderful things about astronomy is that it's looking at the stars and things that we've never seen before. And it's easy to communicate that we're looking for planets around other stars other than the Earth. So we're looking, or to some degree, we're looking to see if there's life elsewhere in the universe. We're looking for the most distant galaxies that have ever been seen. It's a wonderful thing to bring students into science, and there's many, many areas of science that can be applied to astronomy. And it's a way of helping a society excite people about the possibilities in education and in industrial innovation.
I think we see astronomy as being one of those subjects which very esoteric science in many ways, but also very, very accessible. The stars belong to everyone. The skies are visible to all of us. This is a great thing, and to see global community get behind these major astronomical projects, mega projects like the TMT, will, I think, have enormous benefits in the future as the world continues its march toward a globalized economy, globalized society.
We've had wonderful hospitality here in India, so it's been a great visit. Thank you very much.
Yes, thank you.